Hi, welcome to Mathematics with Tom. I am Tom, and today we're going to take a look at section 2.6 in our book. This is titled Solutions to Second Order Equations, and we're going to begin with undetermined coefficients. And I have this example here for you. The problem is we're going to solve y double prime plus y equals t squared, and let's give it some initial condition. It's maybe y of 0 and some initial velocity y prime of 0. To find any, we're going to write our complete solution. So let's do this. Our complete solution, remember our complete solution comes from solving, or not our complete, I'm sorry, our null solution. So let's do this. Our null solution comes from solving y double prime plus y equals 0, and we've done that, and we said that y is equal to, or y null is equal to some constant c1 e to the it plus another constant c2 e to the minus it. Now, this is where it gets interesting. T squared. How do we solve that? This is one we haven't done yet. Well, what t squared is t squared is part of a polynomial. So remember what a polynomial is. Polynomial. It's a polynomial, say f of t. It's just, all it is it's a number times a variable plus another number, a1, times the variable to the first power, plus another number, maybe a2, times the variable squared, plus, and it just keeps going. Where all of the exponents are positive, it ends at some point, maybe some nth term, and it'd be raised t to the n. Well, what t squared is just the first three terms of these polynomials, and in this case, a0 and a1 are 0, and a2 is 1. Well, what we want is we're going to find some particular solution that's going to give us a solution where it works with t squared, but we have to remember that t squared is the third term in this polynomial. So I'm going to write it this way. Maybe instead of a0, a1, and a2, let's just use a, b, c, where my particular solution is something like a t squared plus b times t plus c. There, that's just a polynomial. And now we're going to find out what polynomial is it that solves it. So let's begin this now. So I'm going to need to find y particular prime. Well, that's going to be 2 times a times t plus b. And we need y double prime. Y double prime is going to be 2a. Oh, and that's it. Okay, now remember what we do is now we solve for our a's, b's, and c's by going back to y particular double prime plus y particular equals t squared and see what we get. All right, let's do that. So y particular double prime is 2a plus y particular, which is a t squared plus b times t plus c, and this has to equal 1, I'm going to put a 1 here, 1 t squared. Okay, so now what we do is, well, think about this also, is we also could write this as plus a 0t plus a 0, and now we are going to match up our terms. So let's come up here. So for t squareds, notice the only term that has a t squared is a t squared. So I'm just going to write the a, and that means that this a has to equal the 1. Okay, now let's look at the next piece. The next piece would be anything with the coefficients of t. Well, in this case, our only coefficient of t is a b, and on the right-hand side, we have a 0. And finally, for our constants, For our constants, what do we have? On the left-hand side, I have a 2a and a c. And what else do we know? We know that those have to add to 0. So if we solve this, we know that a is 1. So this would tell us then that c has to equal -2. And there we have it. Our y particular is a, which is 1 times t squared, plus b, which is 0. I'll write it just for bookkeeping here. And then -2. -2. Or, of course, you would clean that up as t squared -2. And remember, we should check our result. So check. So let's take y particular prime. That would be 2t. And y particular double prime, that's going to be 2. So if we substitute those in, we have a 2 for the y double prime, plus then in the y we have the t squared -2. And if we add those up, look at what do we get? We get t squared, and so that works. Check. All right, so I'm going to put this. So this is our solution. Okay, remember you should always check your answers. What I find interesting about this problem is that notice that if we had just started this, I'm going to do this in this reddish color for a warning, don't do this. Notice that if I would have just started with y particular is just some scalar times t squared, well, what I would have missed is I never would have picked up the -2 that was needed to make this problem work. So when you're dealing with polynomials, make sure you start with the term of highest degree and then write out the rest of the terms until you come down to the degree 0 or constant term. All right, we're not done. We need to write our final solution. So we said that we have y of t is c1 e to the I t plus c2 e to the minus I t plus our particular t squared -2. And let's use our initial conditions. Our first one is just some y of 0. Well, that's going to give me a c1 plus c2 -2. And our next one, if we take the first derivative, so y prime of t, that's going to be a c1i e to the I t, and the next one's going to be a minus c2i e to the I t plus 2t. So y prime of 0, that's going to give me a c1, get my 1's and i's mixed up, c1i minus c2i. And then we could solve this system of equations for y of 0 and y prime of 0, and we could come up with our final solution. Let's solve this problem. So we want to solve for our c1s and c2s. I'm going to rewrite my equation like this. I'm going to write it as c1 plus c2 equals y of 0 plus 2. Okay, and my next one is going to be c1 times I minus c2 times I, and that's going to equal my y prime of 0. And then let's see, I can't add anything yet, so I'm going to multiply the first equation by an I, and then I'm going to add the second equation. So we'll call this our first equation, and this will be our second equation. So we're going to do this. We're going to multiply I by the first equation, then we're going to add to that our second equation. Let's see what that gives us. So the c2 components are going to cancel out. So then I'm going to have a 2 times c1 times I, and this is going to equal y prime of 0 plus I times y of 0 plus 2. Okay, let's find out now what C1 is. So C1 is going to be 1/2 of all of this. Y prime of 0 plus I times y of 0 plus 2 quantity. There we go. That's a pretty good looking C1 if I've ever seen one. Let's see what we can come up with for C2 now. For C2, oh, I forgot to divide. This is not 1 over 2. This is 1 over 2i. There we go. That looks much better. Now, so let me just clean that up really nicely. So that coefficient there is not 1/2. In fact, it's 1 over 2 times I. All right, let's find C2. I'm going to use equation 1 to find C2. So that's just going to be, I'm going to write it first off like this. This is C2 equals y of 0 plus 2 minus C1. Well, we know what C1 is, so we can write this as y of 0 plus 2 minus 1 over 2i times y prime of 0 plus I times y of 0 plus 2. And there we have it. Now we have found C1 and C2, and we can write our final solution. This is going to take a bunch of space here. So our final solution, y of t, is going to be C1. That is 1 over 2i times y prime of 0 plus I y of 0 plus 2 times e to the I t plus C2. C2 is y of 0 plus 2 minus 1 over 2 times I times y prime of 0 plus I times y of 0 plus 2 e to the minus it plus our particular solution, which we said was t squared minus 2. And there is the complete solution to our differential equation. In case you forgot what it was y double prime plus y equals t squared with the initial conditions of y of 0 and y prime of 0. I hope that helps, and thanks for watching.